Dear students, now I am starting new chapter, straight lines. In this chapter, first topic is inclination of a line. Inclination of a line. Inclination of line, that means in coordinate plane, suppose this is x-axis, this is y-axis. If any line lies in this coordinate plane and a line, given line makes angle theta, say I have measured this theta in anti-clockwise direction with a positive direction of x-axis. So here this line L makes angle theta with a positive direction of x-axis measured anti-clockwise. Then this theta is said to be inclination of a line. So that is, if the angle theta is made by a line with a positive direction of x-axis, with a positive direction of x-axis measured anti-clockwise, then theta is said to be inclination of that line. So in this diagram, you can see that theta is acute angle. So its measure is less than 90 degree. Now if I rotate this line, if I make this line increasing theta, now theta I am increasing in anti-clockwise direction, and if line is perpendicular to x-axis, then this will be 90 degree. So line is vertical to, if line is vertical or parallel to y-axis, or it overlaps y-axis, then theta is 90 degree. And if theta is still increasing, if it is more than 90 degree, then say like this. Here, in this diagram, this is the theta measured in anti-clockwise direction. Now I am taking this line in upward, so now theta is increasing. So this is theta. Now this line is vertical, so this theta is 90 degree. Now taking theta more than 90, say line is this in this direction. So theta is, this is the theta, more than 90. Obtuse angle. So continuing this procedure, the line is here. So this is the theta. And if I make this line overlapping x-axis, then theta is 180. Or we can say, if line is overlapping x-axis, here theta is 0 degree, because when this line I am taking in clockwise direction, taking this down towards x-axis, then say look here, theta is decreasing. Again, theta is decreasing, going towards to be 0. So continuing this procedure, theta is decreasing. and when it overlaps x-axis, theta is 0. So when theta is 0 degree or 180 degree, it shows same position of line. But when we increase theta more than 180, see what is happening? Here, this is theta more than 90. Continuing this procedure, this is theta again increasing. When it is overlapping x-axis, theta is 180. Now taking still down. So if it is like this, then we don't take theta this angle. This is not taking theta. Because when it comes in this position, then this is theta. So we don't take theta more than 180. We take maximum 180. 180 is theta equal to 180, and if theta is 0, then position of line is same, overlaps x-axis. So in this case, don't take theta more than 180, but observe this side. Here theta is opening towards positive direction. So again theta starts from 0. So here domain for theta is, domain for inclination of line is 0 to 180 degree. So here theta is, value of theta is more than 0, less than 180 degree. Theta can be 0, it can be 180. But for 0 and 180, position of line is same. So any one number you can exclude. We can exclude this 180. Or if you keep as it is, then also it's no problem. So this is the meaning of inclination of a line. Now, using the inclination of line, we can find slope of line. So next topic is slope of line. Slope of a line. See, there are three methods to find the slope of a line. First method is method 1. If theta is inclination of a line, then slope is equal to tangent value of this angle. If theta is the inclination of a line, then its slope, for slope we do not M. M is tan theta. So if we know inclination of inclination of line, then its tangent value gives a slope of that line. Now see, here theta is between 0 and 180. Value of theta lies between 0 to 180. So it covers first quadrant and second quadrant. So if theta is between 0 and 90 degree, or we can say 0 to pi by 2, then this value is positive. So slope is positive. And if theta is more than 90, less than or equal to 180, means theta is obtuse angle, then if you keep any value theta belonging to second quadrant, this is negative. So in that case, m is negative. And if theta is 90 degree or pi by 2, then tan 90 degree is not defined. So then slope is not defined. M is not defined. So any vertical line, for any vertical line, slope is not defined. Still, when line is given line, if it is like this, then here inclination is less than 90 degree. So slope of this line is positive. When line is like this, if line is such that its inclination is more than 90 degree, then slope of such line is always negative. Here slope is negative. So take one point in mind. When you move from left to right, and say moving from left to right, line is going up. Moving your finger from left to right, if your finger is going up, that means slope is positive. Now move from left to right. Left to right. If your finger is going down, say going down when moving from right side, say we are moving towards right side, then slope is negative. And if theta is 90 degree, slope is not defined. That means if line is x-axis, y-axis, this line is vertical. This is vertical line. Vertical line has no slope. So if line is vertical, then its slope is not defined. So first method to find slope of line is slope is equal to tangent value of inclination of that line. Inclination, that means angle made by line with a positive direction of x-axis towards anti-clockwise. So that is the meaning of slope of line. Now to find slope, second method. Method 2 to find slope. If 2 points are given on a line, suppose this is the line and line is passing from points A x1 y1, B x2 y2. If 2 points are given on a line, then formula to find its slope is, say, slope of a line passing through two distinct points. Is two distinct points x1 y1 and x2 y2 is m equal to y2 minus y1 upon x2 minus x1. Difference of their y coordinates upon, in the same order, difference of x coordinate. This ratio can also be taken as You can also take y1 minus y2 upon x1 minus x2. It is same. y2 minus y1 upon x2 minus x1 or y1 minus y2 upon x1 minus x2, that is same. But say if x1 is equal to x2, then slope is not defined. So this is applicable if x1 is not equal to x2. If x1 is not equal to x2, then this formula is applicable. If x1 equal to x2 means x coordinates are same, that means it is a vertical line. And in that case, if x1 equal to x2, then this will be 0. So slope is not defined. So keep remember, if x1 equal to x2 means x coordinates are equal, then AB is a vertical line. In this case, its slope is not defined. Then method 3 to find slope. That is from equation of line. Say slope of a line ax plus by plus c equal to 0. If equation of line is given, we know that this equation represents a straight line. So equation of line, a slope of a line ax plus by plus c equal to 0 is n equal to minus a by b. Minus a by b represents slope of line. That means, as for example, slope of line 2x minus 3y plus 5 equal to 0 is, say formula is minus a by b. So n is equal to minus is a part of formula. Then a, what is a? A is 2. What is b? B is minus 3. The slope is 2 by 3. But this is not defined if b is 0. So here condition is, if b is not equal to 0, then this is defined. If b is 0, then line represents, equation represents vertical line. And vertical line has no slope. So in this method, if b is 0, then equation is of this form, ax plus c equal to 0. This is free from y. Equation is free from y. So if you don't find y variable in equation of line, then it represents vertical line, which has no slope, whose slope is not defined. So that is third method to find slope. Now there are two properties related slope. First property is, if any two lines are parallel, as for example, these lines are parallel, L1 and L2. If two lines are parallel, then they have equal slopes. But slope is defined if line is not vertical. So neither of the lines is vertical and they are parallel, then their slopes are equal. So if neither of lines L1 and L2 is vertical and L1 is parallel to L2, then their slopes, if slope of L1 is M1, its slope is M2. Slope of this line is M1, slope of this line is M2, then M1 equal to M2. Then their slopes are equal. That means L1 is parallel to L2 implies M1 equal to M2. Two parallel lines have same slope, but neither of the line must be vertical. Then second result. If here x, here y, if two lines are perpendicular to each other, L1, L2. If two lines are perpendicular to each other, slope of this line is M1. Slope of this line is M2. They are perpendicular. Then relation between M1 and M2 is their product is always -1. So that is the next statement. If L1 is perpendicular to L2, these are perpendicular lines. No one is vertical. No one is vertical. Because if anyone is vertical, its slope is not defined. So we must have slope of both lines. So if L1 is perpendicular to L2 and having slopes M1 and M2 respectively, then M1 into M2 slope, a product of their slopes is always -1. M1 into M2 is -1. So remember, if L1 is perpendicular to L2, always the product of slope is -1. Here, these statements are true bidirectional. Converse also true. So here L1 is perpendicular to L2, double implies M1 into M2 is -1. Then third property. Measure of angle between two lines. Say, if two lines are perpendicular to each other, suppose this is the first line, L1, and this is the second line, L2, and we want to find angle between them, theta. So here, wherever two lines intersect, we obtain two pair of vertically opposite angles. This is one pair, this is second pair. Two pairs of vertically opposite angles, out of which one pair is pair of acute angle and another pair is pair of obtuse angles. Out of which whatever is acute angle, it is said to be angle between lines. And this angle can be found by formula tan theta equal to modulus m1 minus m2 upon 1 plus m1 m2. Using this formula, angle between them can be found. So here m1 and m2 are slopes of these lines. So if L1 and L2 have their slopes M1 and M2 respectively, such that, see, this value should not be minus 1, such that M1 into M2 is not minus 1. If M1 into M2 is minus 1, lines are perpendicular. But if M1 into M2 is not minus 1, then angle between them can be found by this formula. And theta is measure of angle between them. Then tan theta is modulus m1 minus m2 upon 1 plus m1 m2. So using this formula, theta can be found. So to find angle between two lines, we must have their slopes m1 and m2.
Now question is, find the slope of a line which passes through the origin and the midpoint of the line segment joining the points P whose coordinates are 0, -4 and B 8, 0. So here if we show these points in diagram, this point is on y-axis, this point is on x-axis. So if we show necessary part of quadrant coordinate plane, this is origin whose coordinates are 0, 0. P 0 minus 4, suppose P 0 minus 4, it is somewhere here. P 0 minus 4. B 8, 0. B 8, 0, it is somewhere here. This is a logical diagram. We are not putting points by taking measurement. It's a point on positive x-axis, so keep on positive x-axis side. This is on negative y-axis, so keep in this direction. So diagram should be logically true. Now question is, we want slope of a line which passes through the origin and midpoint of the line segment joining P and B. So this is a line segment joining P and B. Suppose its midpoint is M. So we find coordinates of midpoint. So it will be x1 plus x2 by 2. So that is 4, y1 plus y2 by 2, that is -2. So midpoint, if we say M, midpoint M of line segment PB is x1 plus x2 by 2, y1 plus y2 by 2. So this is 4 minus 2. Now we are asked a slope of line joining origin with this midpoint. So we need slope of line OM. So slope of OM, slope of line OM is equal to, now see here we are having now these 2 points. If we know at least 2 points on that, any line, its slope is y2 minus y1 upon x2 minus x1, y2 minus y1 upon x2 minus x1. You can consider any point as x1 y1, any point as x2 y2. It's not compulsory that O is x1 y1, M is x2 y2. You can also call this point as x1 y1, this point as x2 y2, because as we discussed, slope is y1 minus y2 upon x1 minus x2, or you can take y2 minus y1 upon x2 minus x1. So here slope is y2 minus y1, so minus 2 minus 0 upon x2 minus x1, or you can take y1 minus y2 upon x1 minus x2, value will be same. So it is equal to, this is equal to minus 1 by 2. So this is slope of required line. Now in this question, without using the Pythagoras theorem, show that the points 4, 4, 3, 5, minus 1 are vertices of a right angle triangle. Let me label name to these points. Let me say A is 0.44, B is 0.34, and third point we are giving name C. 3 points, these are vertices of a triangle. So let me find sides of slope. Let me find slope of sides. So slope of line segment AB. Slope of line segment AB is y2 minus y1, y2 minus y1, y2 minus y1 upon x2 minus x1. So it is 1 upon minus 1, so this is minus 1. Now we find slope of BC. Slope of line segment BC or line BC. So it is y2 minus y1, y2 minus y1 upon x2 minus x1. So this is minus 6 by minus 4, so it is 3 by 2. Now slope of AC. Slope of AC, A and C. So y2 minus y1, y2 minus y1 upon x2 minus x1. So this is minus 5 by minus 5, it is 1. Now observe these three values. You can see that product of these two numbers is minus 1. So here it is clear that from this calculation it is clear that slope of line segment AB into slope of line segment AC is equal to minus 1 into 1, that is minus 1. So M1 into M2 is minus 1, and when product of slopes is minus 1, that means lines or line segments are perpendicular. So this means line AB is perpendicular to line AC. That means line segment AB is perpendicular to line segment BC. That means angle ABC is a right angle. So therefore, given are vertices of a right angle triangle. Therefore, given are vertices of a right angle triangle. Find the slope of the line which makes angle 30 degree with a positive direction of y-axis measured anti-clockwise. Say that means here showing this in diagram, Say, read words properly. Line which makes angle of 30 degree with a positive direction of y-axis measured anti-clockwise. So line is making angle 30 degree with y-axis, that means two possibilities. So here it can intersect y-axis like this, or it can intersect like this. Here this is 30 degree, this is 30 degree. Both lines are making angle 30 degree with y-axis, positive direction of y-axis. Now look, this word is important. Measured anti-clockwise. So from y-axis, measured anti-clockwise. So this is anti-clockwise direction. And in this diagram, from y-axis, here this is measured in clockwise direction. We need this line. So we are drawing accordingly this diagram. So here I am showing by that way. This is the line L, and here with y-axis, positive y-axis, measured anti-clockwise direction. This is 30 degree. So we want slope of this line. Now we discuss three methods to find slope. If equation is given, slope is minus a by b. If on a line 2 points are given, slope is y1 minus y2 upon x1 minus x2. But if we know angle of inclination, then slope is tan theta. So we are having here information about theta. So to find its slope, we find angle of inclination, or simply we say inclination of line. So say, look here, in this diagram, inclination of line, that means angle made by line with x-axis, with positive direction of x-axis in anti-clockwise direction. This is inclination of line. So let us find measure of this angle. So say here, this is 30 degree. So this will be 30 degree. This is 30, this is 90. So this will be 60 degree. It is 60. This is 60. So this will be 120. So by from this diagram, calculating inclination is 120 degree. So from diagram, theta is 120 degree. This is inclination of angle, inclination of line. So its slope is, therefore its slope is tangent value of this inclination. So tangent of 120 degree. Tangent of 120 degree, that is tangent of 180 minus 60. Now this value is in second quadrant. In second quadrant, tan is negative. This is it is like pi, tan pi minus theta. So tan pi minus theta is minus tan theta. So this is minus root 3. So this is slope of required, slope of given line. Now here, these points are collinear. Points are collinear. Suppose we put them like this: a x minus 1, b. This is rough sketch. b 2 1, c 4 5. Saying them ABC. ABC. Points are collinear. That means slope of EB is equal to slope of BC, because AB and BC represent same line. So here line EB is same as line BC. AB and BC represent same line, so slope of AB equal to slope of BC. Now slope of AB, so slope of AB is y1 minus y2 upon x1 minus x2. Slope of BC, so y1 minus y2 upon x1 minus x2. So this is 2 upon 2 minus x, 4 upon 4 minus 2 is 2. So that is 2 upon 2 minus x is 2. So therefore this 2 is cancelled. So 1 is equal to 2 minus x. So value of x is 1. Without using a distance formula, show that these points are the vertices of a parallelogram. Let me label names to these points. Suppose this point minus 2 comma minus 1 is A, B is 4 0, C is 3 3 and D is minus 3 2. Now if these are vertices of a parallelogram, then in this parallelogram opposite sides must be parallel. So we are going to show that opposite sides are parallel. There are two pair of opposite sides. So we are going to show that both pair of opposite sides are parallel. And to show that sides are parallel, here we are going to show that their slopes are equal. Slope of these two sides and slope of these two sides. So here we find slope of all sides. So slope of side AB is y1 minus y2 upon x1 minus x2. So it is 1 by 6. Slope of BC is y1 minus y2 upon x1 minus x2. So it is minus 3. Slope of CD, slope of line segment CD is y1 minus y2 upon x1 minus x2. So this is minus 1 by minus 6, so 1 by 6. Slope of AD, slope of AD is y1 minus y2, so y1 minus y2 upon x1 minus x2, so x1 minus x2. So this is minus 3. Now you can see that from this calculation it is clear that slope of EB is equal to slope of CD. Slope of AB equal to slope of CD and slope of BC. Slope of BC equal to slope of AD. If slopes are equal, that means sides are parallel. So because slope of AB and slope of CD are equal, so AB is parallel to CD and BC is parallel to AD. BC is parallel to AD. So that means ABCD is a parallelogram. See, AB is parallel to CD. AB is parallel to CD. See, if I keep here A, here B, then AB parallel to CD. AB is parallel to CD and BC is parallel to AD. So ABCD is a parallelogram. So given are vertices of, given points are vertices of a parallelogram. Therefore given points are vertices of a parallelogram. Now in this question, slope of a line is double of the slope of another line. There are two lines. Slope of a line is double the slope of another line. So we suppose that let slope of lines be, slope of first line is double if slope of another line is k. So let slope of lines be m1 is 2k and m2 is k. Slope of first line is double the slope of another line. So taking in terms of k, 2k, k. If tangent of the angle between them is 1/3, if angle of inclination is, if angle between them is theta, then given that tangent of angle between them, that is given that tan theta is 1/3. So question is find slope of lines. So we are using a formula. Now formula is putting values tan theta equal to, we are putting values in this formula, tan theta equal to modulus m1 minus m2 upon 1 plus m1 m2. Tan theta is 1/3, m1 is 2k, m2 is k, 1 plus 2k into k. That means modulus of k upon 2k minus k is k upon 1 plus 2k square is 1/3. Now removing this modulus, this means k upon 1 plus 2k square is plus 1/3 or k upon 1 plus 2k square is minus 1/3. So we have here two cases. Now we calculate according to these two cases. So here first of all, case 1, k upon 1 plus 2k square is 1/3. That is, now solving this equation, 3k is 1 plus 2k square. That is 2k square minus 3k plus 1 is 0. That is 2k square minus 2k minus k plus 1 is 0. Now here 2k is common. So k minus 1 common, k minus 1 is 0. So k minus 1, 2k minus 1 is 0. So k is 1 or k is 1/2. So if k is 1, then slopes of lines are, see, we supposed 2k and k. So 2k is 2 and k is 1. If k is 1/2, then slopes of lines are, putting here 1 by 2, so 2 into 1 by 2 is 1, and put here 1 by 2, that is 1 by 2. Case 2, k upon 1 plus 2k square is minus 1 by 3. So calculating this, here 3k is equal to minus 1 minus 2k square. So 2k square plus 3k plus 1 is 0, that is 2k square plus 2k plus k plus 1 is 0. So solving this equation, 2k is common, k plus 1, k plus 1 is 0. So k plus 1, 2k plus 1 is 0. So k is minus 1 or k is minus 1 by 2. Now if k is minus 1, then slope of lines are, we suppose 2k and k. So k is minus 1, then 2k is minus 2 and k is minus 1. And if k is minus 1 by 2, then slope of lines are 2 times k, that is minus 1 and minus 1 by 2. So these are possible, there are 4 possibilities. We have found 4 possible answers.